Hello, today I'm going to be presenting my movie review for Physics 101. I chose the movie Fast and Furious. I chose the scene, the skyscraper jump, and I'm going to be analyzing that today. So here is just a link of the full scene if you want to watch that. So the starting point in this scene, we have the car, which is a Lykan Hypersport in the movie. Um, It's inside a skyscraper, which is referring to the first skyscraper in the scene, and this car is accelerating on a flat floor. It then launches off the edge of the skyscraper, breaking through a large glass window. The car then goes into mid-air and travels across a significant horizontal gap between the two skyscrapers. It appears to maintain a slight upward trajectory before starting to descend. With the landing point, the car crashes into a glass window of the second skyscraper, entering another floor. Some context to give is the buildings are tall skyscrapers, estimated to be about 50 meters apart horizontally. I don't know this exactly, but this is just the best estimated guess since I don't have these exact numbers. And the car appears to maintain its structural integrity during and after the jump. So as this scene is very thrilling and cool to watch in the movie, it also comes with questions about the physics involved. The three main questions I had when watching the scene was, could the car actually cover that distance at that height and angle in real life? Would the car's structure hold up after smashing through glass twice? And how fast would the car need to be traveling for this to work in real life? So here I just wanted to include a little diagram to show so you get a bit better visualization. So number one is the first skyscraper, which is the launch point. This arrow right here is a trajectory path that the car I also labeled is taking, which then eventually smashes into the window of skyscraper number two, which is also labeled around here. So some of the overview of the variables and approach I took with this, I wanted to use the projectile motion equation to analyze a jump from one skyscraper to another. The key variables include initial velocity, the speed at which the car launches, launch angle, the angle of the car's trajectory, time of flight, the time it takes for the car to reach the landing point, horizontal distance, the distance the car needs to travel horizontally to reach the second skyscraper, which again is estimated at 50 meters, and then the vertical distance between the two skyscrapers, which I also estimated and took my best guess at, and made that 5 meters. So just to keep touching on this, I'm going to use the following equations to solve for the variables. So horizontal motion, which is this equation where x is the horizontal distance, v is the initial velocity, um, cos is the launch angle, and t is the time. Now for vertical motion, I'm going to do y is the vertical distance, g is the acceleration due to gravity, which is 9.8 meters per second squared, and the other variables are the same as above in the horizontal motion equation. So when I approached this, I kind of listed out steps I did to solve. So first I estimated the initial velocity. I started with the horizontal distance equation to solve for time, which is shown. And I knew that the horizontal distance is 50 meters and the angle is 15 degrees. I also kind of just took my best guess with this since I do not have exact numbers. So I substituted the values that I knew and put that into the equation. So the equation becomes as shown. And then I'll use this expression for t in the vertical motion equation on the next slide. So now that I have that equation, I'm going to solve for the vertical distance. I'm going to substitute the time from the horizontal equation into the vertical motion equation, which is shown here. Substituting. After I have this equation, I'm substituting the time, and then I get this equation, and then I simplify that to make it easier to solve next. Now step 3, calculating the required initial velocity. So using the equation that we got in the previous slide, I'm going to solve for the initial velocity by setting the vertical distance y equals 5 meters, which is the estimated height difference between the skyscrapers. So as shown in the slide previously, I substituted my time and simplified and got this equation. And then I put 5 in for my value of the vertical distance. I also put 9.8 for the gravity and 50 for the 50 for the horizontal distance and 15 for the angle. So after I substitute that, I then calculated the value of 50, which is the horizontal distance, times tan 15. And then I get this, I get 13.4 meters. So then once I get 13.4 meters, I substitute it into the equation again and get a new equation of 5 equals 13.4 minus a half times 9.8 times 50 divided by the initial velocity times 0.9659, and then all squared to the power of 2. So after I got that equation, I now need to solve for the initial velocity. Now I'm heading into my final calculations. So now that I have all the numbers that I needed and I have the initial velocity by itself, I can now solve for it. So I began to solve, and after I did the simple adding and subtracting from both sides, I needed to multiply both sides by -2. After I did that, I needed to divide both sides by 9.8, which I then got 1.71 equals 50 divided by the initial velocity times 0.9659 to the second power. And then continued on the next slide. Now that I'll have that, I have to take the square root of both sides. And then after I square rooted both sides, I needed to solve for the initial velocity. So I did 50 divided by 1.31 times 0.9659. And then I got my final initial velocity 39.4 meters per second. So after calculating the initial velocity, I then had to go back and check my information to see, can this jump happen in real life? So based on my calculations, the jump is possible if the car launches at approximately 39.4 meters per second at an angle of 15 degrees. This required speed is significantly below the Lykan Hypersport top speed of 66.67 meters per second, which confirms that the car has the capability to achieve the necessary velocity. However, practical and environmental factors make this stunt extremely unrealistic in real life. But I want to add one more time that it's not entirely impossible unless it's under perfect theoretical conditions, like I mentioned above. So some factors that make this stunt extremely unrealistic in real life is air resistance. So in my equation, I ignored air resistance in my calculations, but in reality, it would slow the car down during its flight, requiring a higher launch speed. Structural integrity, cars are not designed to endure that extreme forces, such as high speed launch and landing. The suspension, tires, and frame would definitely fail and just fly all over the place upon impact when it hit those windows. Then we have landing precision. The calculations that I performed assume perfect alignment of launch angle, velocity, and trajectory. In reality, even slight errors would cause the car to miss the target skyscraper, which makes um, which is a reason why it just makes it very unlikely to happen in real life. And just a little thing that I wanted to add, but not too much of importance to this scenario, is the driver safety. Because in the scene, the driver was perfectly fine, but in reality, the driver would experience extreme forces during the jump, um, making them have severe risks, causing injury or death, even with advanced safety measures. So, all in all, this could be possible in real life, but it's extremely unrealistic due to the factors that I mentioned and due to the that this would need to happen under perfect theoretical conditions, which again is extremely unrealistic and nearly impossible. So that's all I have. Thank you.